Parametric modeling represents a significant advancement in the field of product design. By allowing designers to define relationships and constraints between different elements, this approach enables rapid adjustments and iterations throughout the development process. Unlike traditional modeling methods, parametric modeling streamlines complex tasks and fosters greater flexibility. As a result, teams can respond more efficiently to changing requirements or feedback. This transformative capability not only accelerates innovation but also enhances precision and consistency in final products. Understanding the fundamentals of parametric modeling is essential for appreciating its core advantages and the ways it is reshaping modern design practices. Parametric CAD offers several significant advantages for modern design workflows. First, it provides enhanced flexibility, allowing designers to make changes to dimensions or features without rebuilding entire models. This adaptability streamlines the process of updating designs as requirements evolve. Second, parametric CAD accelerates revision cycles by enabling quick modifications and automatic updates throughout related components, reducing downtime and minimizing errors. Finally, it improves management of product variants by supporting the creation of multiple versions from a single base model, ensuring consistency and efficiency across product lines. Together, these benefits make parametric CAD an essential tool for efficient and responsive product development. When establishing parametric models, engineers should focus on creating a clear and logical structure from the outset. It is essential to use consistent and descriptive naming conventions for parameters, features, and components, as this improves readability and collaboration across teams. Anticipating future design changes is also crucial. Building flexibility into the model allows for easier modifications and reduces the risk of errors down the line. Best practices include grouping related parameters, documenting dependencies, and avoiding unnecessary complexity. By prioritizing these strategies, engineers can ensure their models are robust, adaptable, and easy to maintain as project requirements evolve.